Okay, so let's go ahead and do a couple of more examples where the leading coefficient or the number in the front is going to be not 1. So here, the leading coefficient is the one which attached to the p-squared is the number 4. And what we want to do again is write out the factors of 4. So can we see here that we have 2 and 2 and 4 and 1 as the factors. So in this case, there's going to be more than one pair. Now, do the same thing that we said in part 2, which is the factors of 8. And 8 times 1. And 4 times 2. Okay. So you can disregard this minus sign. It'll come up at the end when you actually do the factoring part. It'll show up. So you don't even need to worry about it right now. So number 3, or step 3, tells us to take the different options of the first, the different options of the second, and try to find a pairing that multiplies together one of each of them and the other one of the same pairing so that you can add or subtract them to get 4. So let's just pick one. So for example, the first pairing is 2 and 2, and the second pairing is 8 and 1. So if I add these together, we would get 16 plus 2. And I think that's pretty clear that that's not 4. We could also do negative plus. This would be negative 16 plus 2, which also is fairly clear that that's not 4. And then I think if we put negatives on both, is that also fairly straightforward that this would be too big or too small in this case. So let's try it with the last one, which is negative and the second part, and then plus in the front, which is 16 minus 2, or 14. So all those cases fail. And if you're good at mental math, you can do this in your head. But if not, just write them out to make sure that you go through all the cases. Now, you do have to try switching the 8 and 1s to make sure that those fail as well, or maybe it'll work. But in this case, because the two terms here, this 2 and the 2, they're the same, you don't need to switch it. So what we're going to do now is take another pairing. Let's try 2, 2. And then 4 and 2. So this right here gives us 8. This gives us 4. Can we add or subtract to get the 4 in the middle? And if we can see that, it's going to be 8 minus 4, which is going to give you 4. So once we have the middle part found as a product of the two, and then a plus or a minus in the middle of the front, we can get the factors of this again by first writing out the parentheses, putting the variable in the first part, and remember this column represented the coefficients of the p-value. So all we need to do is put the 2's in the front, and then ask yourself the question. This first 2 is this 2, and it's being multiplied to the 4. So does the 4 go here or here? And based on distribution, the 4 needs to go in the second spot. Now this 2 is given by the second 2. And the question is where does this 2 have to go? Well, you don't even need to think anymore because there's actually only one spot left. So the 2 goes here. To finish it off, the signs need to be replaced. So this sign is attached to that 2. And the sign in the front here is a plus, which is attached to the front. Now, the reason why this works, we haven't had a problem with it yet, but before you actually do any of these, the thing that you need to make sure that you do is make sure that this is positive. So we actually need to factor out a negative from the whole thing if it is not. Now, this problem was fairly straightforward, but if you actually look at this, we can actually have factors of 2 here and a factor of 2 here as well, because the GCF in both of them is 2. So what we actually need to do, which would make it a lot easier, is from the very beginning, factor out a GCF. And that's where that -1 factor also comes into play. So let's go ahead and I'll keep that part on the board. But let's try and factor out a 4 first. So if I pull out a 4, we get this, because 4 times p squared is the first, 4 times p is the second, and then 4 times -2 is the last. And what we're going to do now is we're going to factor only on this one part. So that initial instructions, number 1, well, we only have a 1 now in the front. So its factors are, again, just 1 times 1. Whereas in number 2, the factors of 2 is 2 and 1. So now we only have this pair, which makes it a lot easier to deal with. So the question again, add or subtract so that you can get the middle one. And if we have a +2 and a -1, we'll get 1. And so if you could see, what this will do is give us a factored out of 4 here. Maybe I should write it the other way. So let's do this one, and we'll show that it's actually the same as this one over here. So the 1 goes in the front. And don't forget the factor of 4, okay? So this factor of 4 has to go into the front here, because this p squared plus p minus 2 is going to be this factor. The 1, the positive 1, is going to get attached to the 2. So that's going to be a +2. And then the second one is going to be attached to a -1, which is this one. And notice that we get the same answer here and here. However, I think this one is a lot easier to factor. So, and the reason for that, right, is if you pull out the 4, it lessens the amount of factors in the leading coefficient and the last term. So you want to factor things out as much as possible right away. So this problem is fairly big, so let's just go ahead and start. Number 1, factors of 5 is just 5 and 1. But notice in the second one, the factors of 12 are 12 and 1, 4 and 3, 2 and 6, and what's that? And number 3 now says to take all the possible combinations of those. So it ends up being a fairly large problem. But again, 5 and 1, 12, 1, 4, 3, 2, 6. Since the first one has just 5 and 1, those are always going to be here. And now we want to try different options. So, for example, because we have to be able to switch them in this case. So the 12 and the 1 need to be able to flip to both sides. And now ask yourself, add them together or subtract them with a plus or minus here to get that 19 in the front. So can we see that if these are both positive, that's already too small? So subtracting out something will make it even smaller. So this entire case doesn't work. The one on the top though, this is too big. This is 60. So this one also doesn't work just because this is too big. So we need to try something other than 12 and 1. So this case is done. We're already done with that. So let's try 4 and 3. And then the other case with using the same numbers is 3 and 4, so the opposite. So this could be plus 20 plus 3, so that's 23, or 20 minus 3, which is 17. Negative 20 plus 3 is a negative 17, and then negative 20 minus 3 is going to be negative 23 as well. So all of those fail, and if you could do that mental math, it would be a lot faster. This is the one that works. 15 and 4 are the two numbers that you get, and what can you do to them so that they either add or subtract to get to the 19? So this is 15, this is 4, and add them together, you get 19. So using those numbers, we can write out the factors, and again, 2 parentheses, variable, the 5 and the 1, so 5 and 1, and again, ask yourself the question, this 5 gets multiplied to that 3, so this 5 multiplied to that 3. And then similarly, 1 gets multiplied to that 4. Which is that one. So this is the factored form of this polynomial.